When you look up at the night sky, it's easy to imagine the universe as a vast, peaceful space where galaxies drift quietly. However, our galaxy, the Milky Way, is on a colossal journey, speeding through space at over 1,000,000 miles per hour. But where is it heading, and what could be causing this movement? Astronomers believe the answer lies in a mysterious and unseen force known as the Great Attractor. The Great Attractor is a gravitational anomaly located about 150 to 250 million light-years from Earth. Despite decades of research, scientists still don't fully understand what it is. It appears to be a massive region of space that exerts a tremendous gravitational pull on nearby galaxies, including our own. The Milky Way, along with thousands of other galaxies in our local cluster, is being drawn toward this region, which is part of an even larger structure called the Lagrange supercluster. But what exactly is the Great Attractor, and why is it pulling so many galaxies toward it? Let's explore the current understanding of this cosmic mystery. The Great Attractor was first discovered in the 1970s and 1980s when astronomers were studying the motions of galaxies in our local area of the universe. By observing the redshift of galaxies, how their light is stretched as they move away, scientists can measure their speed and direction. To their surprise, they found that many galaxies, including the Milky Way, were not just moving outward due to the expansion of the universe, as expected from the Big Bang, but also toward a specific point in space. This gravitational pull was too strong to be caused by anything within our own galaxy cluster, leading scientists to propose the existence of a massive concentration of matter in a distant region of space. They named this invisible force the Great Attractor. One of the most puzzling aspects of the Great Attractor is that it lies in a region of space that is almost impossible to observe directly. This region is known as the zone of avoidance. It is a part of the sky that is obscured by the thick disk of our own Milky Way galaxy. The dust, gas, and stars in this region block visible light, making it extremely difficult for astronomers to see what's happening beyond. Despite this, scientists have used radio waves, X-rays, and infrared light, which can penetrate the dust, to study the area. These observations suggest that the Great Attractor lies in the direction of the Centaurus and Norma galaxy clusters, both part of a larger structure known as the Norma supercluster. But what exactly is lurking in this region is still largely unknown. While it's challenging to directly observe the Great Attractor, scientists have several theories about what it could be. 1. A supercluster of galaxies. One possibility is that the Great Attractor is a dense region of galaxies, part of the much larger Lagrange supercluster, of which the Milky Way is a member. Superclusters are the largest known structures in the universe, consisting of thousands of galaxies bound together by gravity. The Great Attractor could simply be a particularly dense part of this cosmic web, exerting its gravitational influence on everything around it. 2. Dark matter. Another intriguing theory is that the Great Attractor could be made largely of dark matter. Dark matter is an invisible substance that doesn't emit light or energy, but makes up about 85% of the total matter in the universe. Its presence is inferred from its gravitational effects on visible matter, such as galaxies. If the Great Attractor contains large amounts of dark matter, it could explain the massive gravitational pull we observe, even though we can't see much of it directly. 3. A massive black hole or other exotic objects. Some scientists speculate that there could be a massive black hole or some other unknown object at the heart of the Great Attractor. However, this is less likely, given that we don't observe the extreme gravitational effects typically associated with supermassive black holes, such as violent interactions with nearby galaxies. The Great Attractor is not an isolated object. It's part of a larger tapestry known as the cosmic web. This web is made up of galaxies, galaxy clusters, and superclusters that are connected by filaments of dark matter. The cosmic web forms the large-scale structure of the universe, with vast voids separating the dense regions where galaxies are found. The Great Attractor, along with other superclusters, plays a crucial role in the gravitational dynamics of this web. It pulls galaxies along the filaments of dark matter, shaping the way galaxies move and cluster together. The Milky Way and its neighboring galaxies are being drawn not just toward the Great Attractor, but also toward another even larger structure known as the Shapley Supercluster. The Great Attractor remains one of the biggest mysteries in astronomy. Despite decades of research, its true nature is still shrouded in mystery due to its location in the zone of avoidance and the limitations of our observational tools. However, what we do know is that it is part of a vast and complex cosmic structure, playing a key role in shaping the movement of galaxies, including our own. As technology advances and we develop new ways to peer into the depths of space, scientists hope to uncover more about this enigmatic force. The Great Attractor reminds us that, despite our increasing knowledge of the cosmos, there are still many unanswered questions about the forces that govern our universe. Thanks for watching.